Okay guys, this is the 2007 AP Calculus BC Form B question number 2, and it is on the calculator active part, so feel free to use your calculator. Okay guys, let's jump right into it. An object moving along a curve in the xy plane is at position x of t, y of t, at time t, with dx dt equals arctan of t over 1 plus t, and dy dt equals the natural log of t squared plus 1. For t is greater than or equal to 0, at time t equals 0, the object is at position -3, -4. Note, A says find the speed of the object at time t equals 4. Speed is given by the square root of x prime at 4 squared plus y prime at 4 squared. And we can plug this into our calculators, which we have already done, and it equals 2.912. So part B says find the total distance traveled by the object over the time interval 0 is less than or equal to t is less than or equal to 4. And distance is the arc length formula, which is the integral of 0 to 4 of the square root of dx dt squared plus dy dt squared dt. And we can put that into our calculators, which we already did, and it equals 6.423.
So part C asks us to find x of 4. So x of 4 is the value at t equals 4. You start with your starting point at x of 0 is equal to -3. To find the position at x equals 4, you need to set up an integral. So you have the integral from 0 to 4 of x prime of t. And since we know that x prime of t is equal to arctan of t over 1 plus t, to find x of 4, we have to add the starting point, which is x of 0, plus the integral from 0 to 4 of x prime of t dt. So when we plug it into the calculator, you get -3 plus that entire integral and the answer is -0.892. Part D. For t is greater than 0, there is a point on the curve where the line tangent to the curve has slope 2. At what time t is the object at this point? Find the acceleration vector at this point. Okay, so we know that the slope is equal to 2. We also know that slope is equal to dy dt over dx dt. So the problem tells us that dy dt is equal to ln of t squared plus 1, and dx dt is equal to the arctan of t over 1 plus t. So when you set it up, you can set these two problems equal to each other. T is equal to ln t squared plus 1 over arctan t over 1 plus t. You can multiply arctan to the right side to get 2 arctan t over 1 plus t is equal to ln t squared plus 1. And since these two equations are equal to each other, you know that there is one point where they intersect, and that's the value of t. So I plugged the dy value into y1, and I plugged the dx value into y2. Okay, and since the problem tells you that t is greater than 0, you can set your window, your x-min to 0 and your x-max to 10 to make sure that it's restricted to the first quadrant. So when it's graphed, you see that this point right here is where the two values intersect. You can go to Calc, go to 5, and find where the point intersects, and press enter twice, and you get x equals 1.35766631, and this is your t value. You want to go to your calculator and store this value because you need to find acceleration later. So 1.35776631. Press stow, and I like putting it in alpha A. So the second part of the question asks to find the acceleration vector at this point. So the acceleration vector is just the coordinates at that point. So it's x prime prime of t, comma y prime prime of t. So we know we have to find it at point t equals 1.35776631, and so we have to derive the equations that they gave us. So you don't need to do the derivatives by hand, you can derive this straight in your calculator. So you go to math, 8, and it's d dx, and the first equation is ln of t squared plus 1 at the value that we stored in alpha A. And this is our y value because this is dy dx. So it's 0.955, and we do the same thing for the x value. So we go to math, 8 x of arctan of x over 1 plus x at x equals alpha 8. We get 0.135, and this is the point where the acceleration vector is equal to t equals 1.357661. That's it.
Bye.